Hello everybody, it's old Shazizz here out here in my mad science laboratory. I'm here with my friend Larry, my lab assistants. Him and I have been working on this earth circuit for probably about, I don't know, about a week or so, minus what I've done prior to all that. But I wanted to let you hear from Larry. You see that we're just now getting down to where it's going down to 3.12 volts. And the reason for this experiment right here is to see where we level off and stay at. We were able to get this little simple circuit right here with the LED to remain, what was it, about 2.01,
2.02.
Yeah, 2.0. Yeah, I think it was 2.02. 2.02 volts steady without any decrease whatsoever. So I'll let Larry talk to you for a second and tell you what he's witnessed with this circuit, so you know that there's a lot of people out there that will claim one thing and not be able to prove it. We're essentially trying to let you know that this thing does work. So what do you think, Larry, about the circuit?
Well, I think it's a pretty good ordeal because you're running off of two batteries that were pretty much dead, that you're using the earth to charge back up so that you can use them as a battery, well, as a reserve actually, and then running it through your capacitors to fire the power out of it to run this circuit that you have over here. And it's been running for quite a little bit of time this morning. What, 30 minutes or so?
Yeah, and right now we're deliberately trying to drain it down to get it to stop. And so what we're wanting to see is how long it actually takes to stop, because there's going to be some balance point in the systems at some point. Like right now we're at 3.11 volts, and according to my calculations, you'd have to double check with what you've seen on the video. You can see where it was at 12 and then dropped down to 11, or where it was at 14 and dropped down to 13. And so that's pretty much how long it took for that actual decrease. At some point, what my hopes is that it'll level off like it did with this deal right here alone. The 2.02 was it 2.02? Yeah, it stayed constant. So we knew we could get a constant 2.02 work out of it, and so now we're stepping it up to see how much more we can actually get it to do. If we can get like a solid steady 3 volts, or even get this thing to run on slightly less than 3 volts, then all I have to do is add an extra circuit for each one of these units right here, because each one of them, the entire board itself, all these units here, transmitters, will run off of 9 volts. I can run the entire deal off a 9 volt constant. And so what I'm hoping to accomplish here by this test is to see how long this will stay running. You notice, let me move that out of the way. There's a capacitor bank on the opposite side of this that is actually running that system, that LED down there. And so it's actually charging into there as well. So even after we unplug it, it'll still run for a little while. But what I'm hoping to do is find out where this levels off. If this stops at 3 volts, then I can duplicate that circuit times 3 and run them all into the system and run the entire board with just the dirt alone.
Yeah, and all off of the same rods.
Yeah, just won't have to add any ground rods or galvanized or copper coated. It's just the same rods, but they'll all be basically charging at the same time. So with that said, because you notice when we did our experiments outside, it didn't matter how many rods we put in together, we still came out with the same amount of voltage.
Right.
We ran them in series, we ran them in parallel, and we still came out with the same amount of voltage.
Yeah, but it also depends on where in the yard you put the rods. Because in certain areas of the yard, we weren't receiving very much voltage at all, but in other areas, we were receiving almost a volt of power just off the rods and the multimeter.
And depending on actually how you wire your ground rods together, see we're down to 3.10 now. depending on how you actually wire them together, I was able to get at one point when I first started this. I don't know whether it was due to the moisture in the soil or what the anomaly was, but I was able to get 1.4 volts solid.
Yeah.
And then when I fired up my coils over there, I was able to get it to actually go up to over 14 volts.
Yeah.
So I got a little bit of more motion out of that and was charging that thing a lot faster.
Well, that's when you were sending power back into the ground, basically.
Yeah, when I was dragging electrons out of the earth via the coils over here. See all my. Let me turn this light on for a second. All of my coils. This one wire right here is the ground wire to the entire system. And so what I'm going to do, I'll go ahead and see if I can get some power going on that.
Bad connection.
Yeah, I think that's corroded. There it is. But you notice that lights up, but all the grounds are running through this one particular deal right here. And these are all the grounds. And you notice I got a big jump up in there. But it was a little too much for the whole. It overloaded that circuit. Did you see that?
Yeah.
Watch when I fire that thing up. Let me get that, make sure that's on there. Fire that up. You'll see a massive raise in voltage. But then it overloads that circuit and starts to shut it down. But now look where we're at as far as the volts wise.
It dropped right back down to where it was, pretty much.
Well, actually, it was lower because now it's 3.13 right now.
Yeah, it was 3.10 before you started. Though.
Yeah, it's going down to 3.12 now. But if you did this right, you could actually pulse a high voltage surge into the dirt around your earth battery at the same time, and be able to shake things up a bit, so to speak. You know what I mean?
Yeah.
See, we're getting back down to where we were now. Let me turn that light there off again. Seem to be able to see the voltmeter just a hair better. So, where are you going there?
Oh, nothing. I was just watching me disappear off the screen.
So, what are your thoughts on it, man? You think it's worth looking into more?
Yeah, I think if we built the circuit you were talking about this morning, you know, which is basically this circuit with the transistor in it, and
Yeah.
then
So essentially what he's talking about is a relay switch would probably use too much energy to keep it on, so the voltage would drop too fast, but I believe that a transistor would probably be the best go. And so if we made a circuit board that had capacitors such as, you know, smaller than that, they don't have to be that big, we just wanted a big tank to dump in energy into. And we had a capacitor bank, then a transistor, and then maybe an LED, and have when the system's charging that capacitor up, it'll jump from when that one finally gets high enough, it'll make the flip the switch with the transistor and allow the energy to go into the load, and then the next one and so on down the line. So if you've got multiple banks of capacitors, then you can be charging them all simultaneously, and they'll only discharge whenever they get high enough, and so you can keep them rotating back and forth, so to speak.
you're kind of blurry there.
That's the idea. Oh yeah. Anyway, we'll do some more experiments and get back with you. Say peace to my lab assistant, Larry.
Peace.
Doo-doo. Alright everybody, it's old Shazizz here. We're just now getting down to 3 volts. They're still running. I don't know if you can notice that clock in the background, but I didn't do a very good job of actually timing this whole thing out. But you can see it's still running. And if I take my negative ground off, you can still see it going. So we're getting actual usable energy out of the dirt using this particular circuit. There's no tricks, nothing hidden here or there. And so with that said, just try the circuit out. But there it is. You can see it actually charge back up, and then I'll put my ground back on there and back to the load again. But I'd say this is a plus. There's a clock over my shoulder somewhere back there. I'm going to have to look at this video real close to see exactly how much time it was. Next time I'm going to need a stopwatch or something. But anyway, we're going to keep on testing this thing to see how far it finally gets down. It's at 2.99 volts now. I'm going to see how far it actually gets down before it won't run the load anymore. But so far I'm happy with the results, and I hope you liked the video. Peace and love, everybody. Stay tuned for updates. Take care. That is his cell that he's got going on.
Well, basically what we have here is a 7 to 8 inch long piece of 1.5 inch PVC with 2 end caps on it, full of dirt, and it's got a copper lead and a galvanized lead in it. Now this morning when I started, not even 30 minutes ago probably, when I started with this thing, I run it on the tester and it was reading 0.80 volts. Now this battery has been together like this and made for almost 3 months now, sitting on a shelf not doing anything. And it was reading 0.86 when I made it. Now 3 months later, sitting on the shelf, it's only dropped 6.06. Now I took it outside a while ago and hooked it up to this, hang on, let me get it here, this really small little bitty solar cell out of one of those dollar garden lights, and run it for about 15 or 20 minutes on it, and it went from 0.80 to 0.83 without the cell on it. It actually charged this battery higher than what it had been when it started. And like I said, the only thing that's in it is copper rod, galvanized rod, and dirt. If I can get the cap off of it, I'll show you. Dang, it's stuck on there good.
You're going to sling dirt all over the lab, ain't you?
No, I'm trying not to. I'm going to pull my rod so I can get the top cap off.
I'm about to get dirt in my face.
Well, as you can see, that's
There
all
it
that's
is.
in it is dirt.
Dirt.
Fresh out of the ground. Galvanized wire stuck down on one side in a hole, and the copper wire stuck down on the other side in a hole.